Today's lesson is an intro to series and sequences. A sequence is nothing more than an ordered list of numbers and each number in the list is called a term of the sequence. All right, we represent the term of a sequence by using a variable with a subscript to indicate its place in the sequence. So the subscript indicates the term's place in the sequence. For example, a sub 5 would, and we call this a sub 5, the little 5 is sub 5. A sub 5 represents the fifth term in the sequence. Okay, you can also think of a sequence as a function whose domain is the set of consecutive integers. So for example, if I have this sequence that contains the terms 2, 4, 6, 8, 10, and those numbers, the terms in the sequence would be the range, and the domain would be each term's place in the sequence. Okay, so a sub 1 is 2, a sub 2 is 4, a sub 3 is 6, a sub 4 is 8, and a sub 5 is 10. So our domain here would be 1, 2, 3, 4, 5, and the range would be those terms 2, 4, 6, 8, and 10. All right, so let's just look at some examples of sequences and see what we can find out. All right, we have this sequence 1/3, 2/3, 1, and so on, and we have the 3 dots here. What does it mean when we have this? It just means our sequence goes on and on forever, right? And I think this may be down here. Yes, both of the sequences above, because of this, we know this means the sequence goes on and on forever, which means it's infinite. There's no last term. A sequence that has a last term is called finite, and you wouldn't have the 3 dots that indicate. For the life of me at this moment, I can't think what the 3 dots are called. I'm sure someone is thinking of it. But anyway, this means ... Both of these sequences go on and on forever. They're infinite. There is no last term. So let's see what we can do to complete the table. All right, the term number, remember this is our domain, and I like to label it n. Usually we think of domain as an x value, but for purposes of sequences, I like to use n. And the term, of course, is a sub n. So let's fill in what we have here. 1, 2, 3, 4, 5, 6, 7, 8. And it says write the next 3 terms. Looks like, well, this is just 1, 2, 3, 4, 5. So I've only got to get up to 8. So my first term, my a sub 1, is 1/3, 2/3, 1, and I know that's 3/3. Think of it that way. 4/3, 5/3. What's going to come next? 6/3, I think, which is 2, of course. 7/3, 8/3. So we got our table filled in. So now what we got to do, guys, is figure out a rule, or in other words, a formula that would allow us to say, okay, what's the 15th term? And we could figure that out without having to write the 9th term, the 9th, the 10th, the 11th, and so forth. We want a rule that's going to enable us to figure out what any term in that sequence is based on where its place is. So let's think about what's going on here. Okay, what is happening? How does our n relate to our a sub n, or our domain relate to our range? Well, it looks to me like what's going on, whatever n is, I'm dividing it by 3, right? That looks like what's happening. So it looks like I have n over 3, or what's another way we could write that? We could write it as 1/3 n. Okay, so now that I have my rule, it says find the 10th term, a sub 10. So all I got to do is say a sub 10 is n, which is 10, over 3, and there we go. Simple as that. I have found my 10th term. What would a sub 30 be? A sub 30 would just be 30 over 3, which would be 10. right? So we could find any term in that sequence because we found the rule for arriving at those terms. Okay, let's see what we have now. We got 2, oops, sorry. I'm supposed to be writing the term number here. The term number here, n, a sub n goes here. So the first term is 2, second term is 5, third term is 8, fourth term is 11. I got to write the next 3. The fifth term, well, I can easily see they're going up by 3s. So this is going to be 14. Sixth term is going to be 17. Seventh term is going to be 20. So now what I got to do is come up with a rule. And guys, it's not going to be as easy as saying n plus 3, because if you think about it, if I add 3 to 1, I get 4. So we have to be very careful. In this case, we're trying to figure out how the term itself relates. So the term itself relates to its position in the sequence. So let's see if we can think of something that we do to n every time, and then we get the term itself. Okay, so what if we just multiplied n by 2? Well, we would get the first term, but then if we multiply 2 by 2, we just get 4. So it's not 2 times n. That can't be what it is. How about if we multiplied n by 3? I mean, you kind of just have to think about this. And one of your thoughts might be, well, what if I add 1 to n? If I add 1 to 1, I do get 2. But if I add 1 to 2, I get 3 and not 5. So you kind of got to play around with this for a little while. And what you'll finally realize is that what if I multiplied 1 by 3? How would I get 2? I would subtract 1, right? What if I multiplied 2 by 3? I would get 6, and then if I subtracted 1, I would get 5. What if I multiplied 3 by 3 and subtracted 1, I would get 8. And so all the way down, I can see that if I multiply n, the position in the sequence, and then subtract 1, I'm going to get the term that I need. So there is my rule. This took a little bit of work to figure out, but sometimes you just got to work a little. Okay, so now to find the 10th term, I'm just going to plug in 10 for n. So I got 3 times 10 minus 1, so that's 30 minus 1, which gives me 29. So without having to fill out my whole table, I can go and find any term I want to in that sequence because I found the rule. All right, so here we go. We're supposed to do some practice. For each sequence below, write the next term and write the rule. So I always like to make my table, guys. I like to make my little n and my a sub n. And what have I got here? I've got 1, 2, 3, 4 terms. 1, 2, 3, 4. And I got negative a third. I got positive 1/9, negative 1/27, positive 1 over 81. So a sub n, let's see what we got here. I can see that my numerator is staying 1. Well, it's actually alternating between positive 1 and negative 1. So let's see what we think about this. And what's happening is it looks like my denominator, look at my denominator, I'm going 3, 9, 27. So how do those denominators relate to n? Well, it looks like I'm raising 3 to the power of n, right? Because if I got 3 here, think about 3. If I raise 3 to the power of 3, I get 27. Here, if I raise 3 to the power of 2, I get 9. If I raise 3 to the power of 1, I get 3. So that's what's going on here is I've got 1 over 3 to the power of n, but it's also got to be negative, right? So that looks a little confusing. What I actually want to do is I want to rewrite this. I want to put my negative out here, 1/3 in here. No, not quite. I got to leave my negative in the parentheses because every time it gets raised to the next power, it's going to alternate. So what this is going to give me is negative 1/3 to the nth power. Okay, so there's my rule. Takes a little bit of work to figure that out. And I need the next term. Oh, it says I only got to write the next term. So I got to put it up here because I don't have enough room. So a sub 5, I'm going to use my rule now. So a sub 5 is negative 1/3 to the 5th power, right? So that's going to be a negative. It's going to be a negative because I'm raising a negative to an odd power. So that's going to be negative 1 over 3 to the 5th power. It's going to be 243. So there's my 5th term for sequence A. All right, let's try this one. I like to make my table, kind of like an XY table. Actually, it is an XY table because remember we said this is the domain. This is the range. But instead of XY, I like to call them N and A sub N. So our first term is 2. Our second term is 6. Third term is 12. Fourth term is 20. All right, so let's see what's happening here. This is a good one. Well, the 5th term is easy enough to find because what you can do is you can say, all right, let's see. I'm going up by 4 here. I'm going up by 6 here. I'm going up by 8 here. So I know I'm going to have to go up by 10 here. So the 5th term is going to be 30. I'll write that here. But guys, knowing how much the terms increase each time doesn't really help me in finding an explicit rule. It will help me shortly when we talk about recursive rules, but what I got to do is find out how each term relates to its position in the sequence. So let's see, what can we do to n each time to get a sub n? Well, if I multiply 1 by 2, I get 2, but if I multiply 2 by 2, I only get 4, so 2n doesn't work. Let's see what we got to do here. How about if I multiply n? If you look here guys, if I multiply these two together, I get 2. If I multiply 3 and 4 together, I get 12. If I multiply 4 and 5 together, I get 20. Multiply 5 and 6 together, I get 30. So that's going to help me write my rule. So what am I doing? I'm multiplying n by n plus 1, right? If I multiply 1 by 2, I get 2. If I multiply 2 by 3, I get 6, and so forth. So there's my rule. And of course, you could write it as n squared plus n also. It just makes a little more sense to me this way. So I would probably leave it just like that. Okay, so if I use this rule to figure out what the 5th term is, a sub 5 equals 5 times n plus 1, which is 6, then I do get 30, which I figured out in a different way. Okay? Let me erase that because now I'm in my way over here for our next notes, which are on series. Okay, so a series just means that I'm going to take a sequence and I'm going to add the terms of it. Okay, a series is just taking the terms of a sequence and adding them, and of course we want to find the sum. We want to find the sum of all those terms. We can use sigma notation to find the sum. Here's a sigma, this large Greek letter here. Sigma notation means I'm going to find the sum of all of these things. So this means sum, of course. I use the sigma notation to designate sum. And look here what all of our little subscripts mean. Okay, this little I equals 1, that means I'm starting with the first term. That's where I'm going to begin. It doesn't always have to be 1. You can start with the second term or any term, but in this case, it says we're going to start with the first term, and n tells me how many terms of the sequence I'm going to add. So there's your n, upper limit. This is the lower limit down here. Okay, and then a sub I is just each term in the sequence. So as I goes from 1 to n, I'm just going to add a sub 1 plus a sub 2, just like is written here, all the way up to however many terms I want. Okay, so let's give it a try. What does this mean here? It means I'm going to start with 1, and I'm going to end with the third term. So I'm only going to add up 3 terms. So I'm going to first let I equal 1. So that's going to be 2 times 1 plus, then I is going to go to 2. So it's going to be 2 times 2. And then finally, our last term is going to be the third one. So that's going to be 2 times 3. So I get 2 plus 4 plus 6, which equals 12. So that's how we use that. Okay, what are we going to do here? Well, we're going to start with I equals 2. So we're going to get 2 squared. And then, guys, this minus 1, for me to subtract the 1 every time, this would need to be in parentheses, but it's not in parentheses. So what I got to do is I got to do 2 squared plus 3 squared, and I'm stopping at 4, plus 4 squared, and then I got to subtract the 1. So I got 4 plus 9 plus 16 minus 1. And let's see what that gives me. 13 plus 16 is 29. 29 minus 1 is 28. And finally, oh, anybody remember this? Hopefully, I don't know if we've done factorials this year. I can't remember, but maybe you've done it before. This exclamation point means factorial. And factorial just means for instance, if I have 5 factorial, that just means I multiply 5 by all the numbers that come before it. Okay, so what are we going to do with this? Well, we're going to start at 3. We're going to start at 3, and we're going to take the sum of 3 factorial plus 4 factorial plus 5 factorial. So let's see, that's 3 times 2 times 1 plus 4 times 3 times 2 times 1 plus 5 times 4 times 3 times 2 times 1. And what does this give us? Let's see, that's 6 plus 12 times 2 is 24 plus 120. So that's 30. So altogether, that's going to give us 150. So that's how we use the summation. All right. Write each series below using summation notation. Okay, well, let's give it a try, kind of doing it in the reverse order. So maybe it might help us to make our little table here, n and a sub n. And our first term is 5, our second term is 10, our third term is 15, and so it goes. So let's see, what are we doing? What are we doing each time? Oh, we're multiplying n by 5, because 1 times 5 is 5, 2 times 5 is 10. So what we got here is 5n, right? And where are we starting? Well, we're starting with n equals 1. And since we're going down here to 100, then we got to figure out what our n is on the top, right? What is the n? What do I multiply by 5 to get 100? 20, of course. So that 20 has to go right up there. All right, let's try another one. Make our table. N and a sub n. First term is a half. Second term is 2/3. Third term, 3/4. Fourth term, 4/5. And so it will go. So let's see what's happening here. We got the sum. And what am I doing? I have, okay, in each case, n is 1 here, I've got 1 in my numerator. N is 2 here, I've got 2 in my numerator. So I'm pretty sure that my numerator is n, and the denominator is 1 more each time. So that's going to be n minus 1 here. And so I'm starting at 1, and I don't know how high I'm going. I mean, it goes on and on forever, right? So I'm just going to put an infinity up here because it's an infinite sequence. This one here, number 11, what we say this is, if it has a last term, it's finite. But number 12 is infinite because there is no last term. Okay. Finally, what do we got here? Find the first 8 terms of the sequence 2, 6, 12, 20, and then find the sum of the first 8 terms. All right, let's make our table. N and A sub n. First term is 2. Second term is 6. Third term is 12. Fourth term is 20, and so on it goes. And we want the sum of the first 8 terms. Well, of course, first we got to find the rule. We got to figure out what A sub n is. What is our rule? What's going on here? Well, it looks like maybe I'm taking n. I think I've already had this one, haven't I? I've already had, yeah, we had this right up above, 2, 6, 12, and we figured out the rule. We had this way up here somewhere. Right here, right here, same one. So we got our rule, n times n plus 1. All right, so we got the sum, and we're starting at 1, and it tells us to find the sum of the first 8 terms. So we're going to stop at 8 of n times n plus 1. So if we plug in 1, that gives us 1 times 2 plus 2 times 3 plus 3, oops, times 4. Let me fix that. Well, plus 4 times 5. I think it might actually be easier to come over here to our table. And let's see, we know we're going up by 4, 6, 8. We know this one's 30. This one's going to go up by 12, so that's 42. 7, that's going to, let's see, 12. This will go up by 14, so that'll be 54. And the 8th term is going to go up by 16, so that'll be, oops, I may have just messed up here. 42. Yep, sorry. This one's 56. This one's 56, and then this one will be 72. So if I keep going all the way out here, I'll end up with 72. And finally, if I add all these together, I'm going to end up with 240. So there is the sum of the first 8 terms. And that's all we have for today. So we'll see you next time when we talk about recursive sequences.